ready to do right now. Okay, so tomorrow we are, wait a minute, Jackman.
Uh-oh.
What time's that clock say?
Jackman.
Our phone is slow.
You know what, honey? I couldn't care less. You are now going to join the Audi list.
Central time is different.
You should write above the audio.
Yes, but those are getting ready to go to detentions. You bring me in a full-size box of non-generic Kleenex, full-size box, okay?
Okay.
Or you go to detention, it's up to you.
I would take the detention.
I will be happy to give you one. All right, our quiz tomorrow, we'll have 2 problems, and there'll be something like this. Find the cotangent of pi over 6. Okay, we already reviewed a couple of these earlier, just doing another one to get warmed up before we forge ahead with our lesson. Find the cotangent of pi over 6. So what's the first thing we're going to want to do?
30.
Well, first, we're not doing this on our calculator, we're doing this by hand. So we're going to think of this as cotangent 30. Now, Corey said 1 divided by tangent. If I were typing this in on my calculator, that's what I would do, right? But when I'm doing it by hand, I want to change that to degrees. Then I'll draw my picture and put a 30 here. All right, now here comes the critical part. What goes here?
Root 3.
No.
6.
2. What goes here?
1.
Root
1. And this one is root 3. That is what you absolutely have to memorize. You're going to miss all these. Across from the 30 is a 1. Across from the 60 is root 3, and the hypotenuse is 2. Now we can use Corey's idea, because when I look at SOHCAHTOA, cotangent is not up here. Cotangent isn't here. So I have to remember that cotangent is the reciprocal of the tangent. If tangent is opposite over adjacent, then cotangent is adjacent over opposite. So, adjacent over opposite. So the answer to the problem would be root 3. Okay? Is that all right with everybody? Okay, again, 2 problems just like that on the quiz tomorrow. We will review beforehand, but you must get this memorization done. Okay? All right, it's time to look at part 5, which is wild and wacky. Part 5 says there is an angle. There is an angle out there whose cosine is 1/2, and your job is to tell me how big the angle is. This will actually help you with your memorization. Let me draw my picture, the same one I've drawn for all my problems today. And here's theta. Remember, the angle's always at the origin. Now, what do I know about that theta? I know that its cosine is 1/2. Now, what does that mean in terms of the triangle here? This is a 1, and this is a 2? Now, wait. Have you seen those 2 numbers before? Are those special numbers? Exactly, Joe. That's a 1, that's a 2. This one's got to be a root 3. And what angle is across from the root 3? 60. So the answer to the question is 60 degrees. You're just working it backwards. You're working a 30, 60, 90 triangle backwards. Let's try the next one. The sine is root 2 over 2. I hate this problem because it's tricky. It's tricky. That is the same as 1 over root 2. Now, before you say anything or get confused, I want you to stop for a minute and think. Are you allowed to have a radical in the bottom?
No.
No. So if you took this answer and you got rid of the radical in the bottom, would it give you this? Yes. So instead of thinking about it in the simplified form, I'm going to think about it in the unsimplified form. Because the number 1 and the number root 2 are parts of one of my special triangles. Would you agree? The 45, 45, 90. So here's my picture. The sine is 1 over root 2. Opposite over hypotenuse. Opposite over hypotenuse. Well, if that's a 1 and that's a root 2, isn't this also a 1? So as Jalen G already said, this is a 45, 45, 90 triangle. And the answer to the problem is 45 degrees. These are tricky, kids. I mean, actually, they're not tricky, they're just complicated. There's so much you have to think about. All of your trig functions are fractions. So if all you have is a plain number, think of it as over 1. That's 2 over 1. Think about SOHCAHTOA. They're all fractions. Opposite over hypotenuse, adjacent over hypotenuse. They're all fractions. Okay? What do you think? Somehow I got it in this triangle, I have to put a 2 and a 1 somewhere. Where do you think I should put the 2 and the 1? That's cosecant, which is the reciprocal of the sine. So opposite over hypotenuse would be 1 over 2, the flip of that. So opposite and hypotenuse. Have we ever seen a triangle with those two numbers before? What's the other side?
30.
Root 3. How big is the angle that's across from the 1? 30. The answer to the question is 30 degrees. Very, very good. Theta is 30 degrees. Perfect. This is tough stuff. So tangent equals 1. What's tangent? Think of that as a fraction, 1 over 1. What's tangent? Opposite over adjacent. So we have 1 and 1. That side would have to be root 2. That's a 45-degree triangle, so theta is 45 degrees. Perfect. All of these, if you're doing them with no calculator, all of them are going to be 30 or 60 or 45. They have to be without a calculator. All right, secant equals 2 over root 3. Malcolm, do you have any idea how to handle a secant? What's going through your head when you see secant?
The opposite
Of?
Sine.
Cosine, that's exactly right. It's the opposite or the reciprocal of cosine. So cosine So cosine is adjacent over hypotenuse. So this must be hypotenuse over adjacent. So I can label my triangle hypotenuse is 2 and adjacent is root 3. The other side, I heard somebody say it has to be 1. What angle is across from the 1? 30. The answer to the question is 30 degrees. You guys are doing great. This is complicated, but you are figuring it out. Good work. One more. Cotangent is root 3. Put it over 1. Anytime there's a plain number, put it over 1. Got to have a fraction. Picture is always the same. What do you think of when you think of cotangent?
Tangent.
You think of tangent, actually the flip of the tangent, right? So tangent, so kotoa is opposite over adjacent, so this must be adjacent over opposite, would you agree? So adjacent over opposite, remember the opposite is once across from it, so that's a 2, and that's 30 again. Every time we do this kind of thing, kids say, Miss Ford, we keep getting the same answers. Yeah, it's always going to be 30, 60, or 45, unless we have a calculator. Okay? Speaking of which, now we're going to actually do some solving with our calculators. You have done these kinds of problems before. You may not remember it, but you certainly did them back when you were in geometry class. So we're going to use trigonometry to solve this triangle. Actually, just to find x. We're not solving the whole triangle, we're just finding x. Okay? This, by the way, is a very, very practical type problem. Let me give you an example of where this might come in to play. Let's suppose that there is your favorite cat has climbed the top of the tree. And you know the tree is 10 feet tall, or you know the cat is 10 feet off the ground. And you've got a little instrument, it's called a sextant, that tells you the angle of elevation. You want to know how far you are away from the cat. Well, you can use trigonometry to figure that out. Here are your options, Zion. I'm using a calculator. So my options are sine, cosine, and tangent. I want you to look carefully at the problem. Look carefully at the only angle you've got other than the 90, which doesn't count. Should I be setting up an equation using sine, cosine, or tangent? Why sine?
It's opposite.
Yes! In the problem, relative to the 28, this is the opposite side and this is the hypotenuse. The function you have, sine, cosine, tangent, the function you have that ties together opposite and hypotenuse is sine. Armand, you with me? Okay. So sine 28 equals opposite over hypotenuse. I don't go to the calculator yet. We are trying to solve for x. We want to get x by itself. So I'm going to multiply it over to here. In other words, I'm going to get rid of that fraction. So I'm going to multiply x over here. Now what will I do to get x by itself? Divide. So 10 divided by sine 28. And that's what I'm going to type into my calculator. But wait, is that 28 a degree measure or a radian measure? It's a degree measure. So the first thing you do when you turn on your handy dandy calculator is go to mode, Jane. Right? we go to mode and make sure that we have degree highlighted. And then we'll do 10 divided by sine 28. Did you get 21.30? And I don't know, there's no rounding instruction, so I'm gonna understand. We'll do whatever they tell us to do. Well, that was easy, wasn't it, Jalen Buford? Let's try the next one. These are all degrees, so we'll have to be careful with degrees. All right, Ike, you got an idea? Remember, you're going to write an equation just like this, and it's going to use either sine, cosine, or tangent because those are the only ones on our calculator. So what do you think when you look at that? Why would you are right. I would too. Why? It's adjacent hypotenuse. The two sides you have relative to the 13 are adjacent and hypotenuse. So cosine 13 is adjacent over hypotenuse. Now take a clue from the last one we did. What is the first thing you want to do, Caroline Brown, to solve this? So we're going to multiply x over to this side, and then Caroline, we will, oh, not x, 4, and then what? So 4 divided by cosine 13 is going to be the answer to the question. 4 divided by cosine 13. Did you get 4.11 basically? Now eventually these are going to become word problems. The only difference will be you'll have to draw your own picture based on the words, but the work will be exactly the same. Okay, all right, well let's stop there because I think the period's over. So good job. Bring those calculators tomorrow. Not today. Have a great day, everyone.
You should at least get your name high.
Why are you writing your name on the board? I know you did.